3.3 extension, linear programming. Please complete the warm-up and pause while you do your work. After you're done working, then pause and compare your work with my work. Once you've filled in the blanks, graph each of the equations by finding the c-intercept and then the t-intercept, treating your c like your x and your t like your y. Now compare your work with my work. For c plus t equals 120, I found the c-intercept to be at 0, 120, and the t-intercept to be at 120, 0. I showed you a little bit more work for the equation 4c plus 8t equals 800. For the c-intercept, t equals 0. So if that goes away, I'm left with 4c equals 800. Dividing both sides by 4, I get c equals 200. Repeating the same steps for the t-intercept, I get 0, 100. You'll notice that by about the fourth graph, I stop shading in completely and only start shading in the area that matters. For us, we will focus on this area. Vocabulary. Optimization means finding the maximum or minimum value of some quantity. Linear programming is the process of optimizing a linear objective function subject to a system of linear inequalities called constraints. For your warm-up problem, these would have been known as your constraints. The graph of a system of constraints is called the feasible region. This would have been our feasible region. Optimal solution of a linear programming problem. If an objective function has a maximum or minimum value, then it must occur at a vertex of the feasible region. Moreover, the objective function will have both a maximum and a minimum value if the feasible region is bounded. Should kind of make sense. If it's not bounded, then this one, for example, could go on forever and ever and ever, and there really would not be a minimum value. Example 1. Find the minimum and maximum values of the objective function c equals 3x plus 2y subject to the following restraints. Step 1 tells us to graph the constraints. Do this the same way that you did on the warm-up. When you're done, check your work with my work. You may pause now. Check your graphs with my graphs. Make sure that your shading areas match mine. What was tricky about this problem was that although it says less than, which would make you want to shade below, because this y has a negative sign in front of it, you end up shading above it. If you need to, make corrections now. If not, let's proceed to step 2. Find all of the vertices. Note, if the vertices do not fall on the corners of the graph, then you need to algebraically solve for the intersection points. Some of the vertices are easy to find. Here's one at 0, 0. Another one is at 0, 5. And if we look over here, this point which we labeled is 5/3, 0. This point is a little bit more complicated. In order to find where these two lines intersect, you will need to solve this system of equations by using either linear combinations or by using the substitution method. Looking at these two equations lined up, I see that it will be easy for me to multiply this one by -1 so that I can get opposite coefficients, which we learned about in a previous lesson. My new equation on the bottom is -3x plus y equals -5. From here, we see that 5y is equal to 15, which means that y is equal to 3. You may plug this value into either of these two equations to find the value of x. X is equal to 8/3. So my last vertex is 8/3, 3. Step 3 asked us to plug in each vertex into the equation to find the c values. The equation that you'll be plugging into is c is equal to 3x plus 2y. You may use your calculator to make the calculations a little bit easier. For the point 0, 0, however, c is equal to 0 plus 0, 0. For the point 0, 5, c is equal to, this is 0, plus 2 times 5, 10. Now that I've done the easier points, plug in 5/3 and 0, as well as 8/3 and 3 into your objective function. You may pause while you do this. After plugging in the remaining vertices, I found that for 5/3, 0, c was equal to 5, and for 8/3, 3, c was equal to 14. If you had any difficulty, go ahead and use my work now to check yours. It looks like the maximum value is 14, and it occurs at 8/3, 3, and the minimum value is 0, and it occurs at 0, 0. Write your answer in a complete sentence now. Check to make sure that your sentence is similar to my sentence. Example 2. Refer back to the warm-up problem. The objective function would be p equals blank c plus blank t, where c still represents the number of cats and t represents the number of t-shirts sold. What would the maximum profit be? In order to solve this, we have to figure out what the profits would be for each item. In the original problem, it said that t-shirts could be bought for $8 and sold for $12. So for t-shirts, my profit would be $4. T-shirts, $4. For caps, we would buy those for $4 and sell them for $7. So your profit would be $3. This is your objective function. From here, you'll do the same things that we did for example 1. We've already graphed our constraints. Now we'll need to find our vertices, plug them into our objective function, and then find out where our maximum profit would be. Going back up to your graph, the same way that we did for example 1, label each of your vertices. I've marked each of my vertices in black. The first one is at 0, 0. My next one is at 0, 100. This one is 120, 0. From here, solve this system, your red and green lines, my red and green lines, for C and T. Do this using either substitution or linear combinations. Pause now and then check your work with my solution. My fourth vertex happens at 40, 80. You would get this if you did elimination or the substitution method. This time, I used the substitution method. Seemed like it took a little bit longer for me. Your next step is to plug each of these 4 vertices into our objective function. T equals 3c plus 4t. From there, you'll be able to answer the question, what would the maximum profit be? Plug in each value and see where your maximum is. You may pause now and then check your work with my work. Check your work with my work. For 0, 0, I got P equals 0. For 0, 100, I got P equals 400. For 120, 0, P was equal to 360. And for 40, 80, P was equal to 440. So, the maximum profit would be $440. This is obtained when 40 caps and 80 shirts are sold. Thank you very much. Enjoy your day.